Hey everyone, and welcome back to the channel. All right, today I have a very, very special guest for you, and we are going to talk about the subject that, gets people a little roughed up a little bit about oil and oil changes, frequency, type of oil, and all of that good information. So, as you can see right here, join us, Mr. Lakespeedjr with the YouTube channel, Motor Oil Geek. I always hate saying the Motor Oil Geek, but that's what your channel is. Going on, Lake.
I'm good, sir. I kind of went with it, right? My kids used to say I was an oil nerd, so I just kind of, heightened it up a little bit, right? Try to make it elevate, not nerd. I'm a geek. I am kind of a geek at heart when it comes to tribology, which is the study of friction, wear, and lubrication. So, love this stuff. Have lots of experience with it, so I'm happy to share that.
Yeah, I'm
with
glad you
everybody
said
watching tonight.
tribology. Am I saying that right?
Yeah, tribology.
Tribology. Okay, good deal. So, and that's a little bit different. That's studying friction, but your oil and lubrication specialist, is that a different certification?
That is, so the
Sort of.
certified lubrication specialist, that comes from the Society of Tribologists and Lubrication Engineers. So STLE is, I wouldn't say a sanctioning body, but they're very similar to what like SAE is for the automotive industry. STLE does a lot of the same things for the lubrication engineering community.
Gotcha.
So I'm a member there and speaker at conferences and meetings and things like that. Again, I'm motor oil nerd. Love tribology. I love the science of it. Like I say on the channel all the time, I hate oil marketing. I'm not a big fan of a lot of the branding and the different things that oils do to try to be sold. But I try to cut through to it, to the end user's perspective. Like, what's right for me? How do I make sure that I'm getting the best protection, best, value out of what I'm doing? You don't want to do extra work, spend extra money. So let's do the right amount of work, spend the right amount of money to get the best possible result.
Yeah. And that's one thing that I want to, there's a little bit of politics involved when it comes to frequency of oil change and what manufacturers recommend versus what engine guys or gals or whoever, just car enthusiasts in general. And so one of the things that's always, and someone's watching this right now, likely watching it from a link in a forum, and they're adamant that you have to follow the manufacturer's recommendations at 10,000 mile intervals or whatever it is listed, whatever type of vehicle it is. And that is it. And then someone's uncle said it was 3,000. And then new engines are built from a tolerance that is no longer requires break-in, or you don't have to change the oil because you don't have the results of what normally happens in an engine during a break-in. And so we're going to cover all that today. And the very first thing I want to talk about, wear versus friction. Now, you think friction, higher friction, more wear, but that is true or not true?
Friction and wear are two independent phenomenon. They're not related. So friction's not the opposite side of the coin of wear. You can have an oil or a situation where you're creating very high friction with very low wear. Inversely, you can have very low friction with very high wear, or any combination of the two you want. So the chemistry allows for that. It's just that people typically think, oh, if I reduced friction, therefore I reduced wear. No, that's not the way it works in real life. And sometimes if you increase friction, you can be reducing wear. ZDP, zinc, are everyone's favorite buddy, especially if you have an older engine and a flat tappet cam. You're very familiar with ZDP. It actually increases friction. Now, it does decrease wear, unless you used in moderate amounts. It decreases wear. If you go too crazy, it's kind of like Goldilocks and the Three Bears. Not too hot, not too cold. You want to just right. With ZDP, it's the same thing. You don't want too little. You don't want too much. You want just the right amount. But that ZDP that reduces wear increases friction.
So new engines, let's, for example, we could talk about let's just say modern day off-road vehicle, whether it's a Bronco, a Jeep, a 4Runner. So let's just think modern day, naturally aspirated is in one column. Then we have boosted in another, so turbo. manufacturers, what kind of hone are they putting an aggressive hone on these new sleeves and then and pairing it to a ring? Or is it, I would say that if they're trying to reduce or not use break-in oils, it's probably a smoother sleeve and a
They tend to be
ring that doesn't
smoother.
break
Yeah.
down.
So what they tend to do, especially in naturally aspirated engines, they'll go with a smoother hone with a moly faced ring. So that's going to be probably either a steel or an iron ring that has a channel cut in the face of it, and then it's filled with molybdenum. And that molybdenum, not only is it lower friction and anti-scuff, but most importantly, it's sprayed in, so it has porosity. And that porosity allows it to hold oil. So now that the hone can be smoother, it doesn't need to hold a bunch of oil because the ring's going to hold the oil. And that works pretty good with, NA engines. The problem when you go to boost is the boost and any kind of detonation will knock the moly out of the ring. So then you're typically going towards a steel ring that maybe is nitrided or PVD coated. Neither one of those have natural porosity. So in that case, the hone needs to be more plateaued, or they'll use some kind of spray liner that spray in liner has porosity so that you have some place to hold the oil, because the oil isn't just a lubricant. It's a gasket between the piston ring and the cylinder wall. So you got to have a place to hold it. And, my day job working at Total Seal, we spend like literally all day, every day talking about this. Because it's like, okay, you want this type of ring. What's your application? Do you have the ability to hone the engine block appropriately for that ring material? Just because you want it, it's not going to work very good for you if you don't have the ability to create the correct surface finish for that ring material. Engines are systems.
Right. Yeah, everything
they all have to work together.
Sometimes people skip over an intro, so I want to make sure I make it very clear now. So when it comes to performance engines and just performance in general, you come from, the NASCAR sort of is in your family, right? So your dad.
Yeah, my dad was a NASCAR driver for 20 years. Owned our own race team, built our own engines. And then after all of that, I spent 13 years working for Joe Gibbs Racing in the engine department and handling their oil program.
Wow.
And part of that, we were able to work with one of the 4 largest companies on the planet in terms of oil additives. So there's all these different brands of oils. Think about every brand of oil you've ever used, whatever brand you're using now. Then you got to realize there's only 4 companies on the planet that make the additive packages that go into every oil.
And the additives is the critical part.
Base oil and additive. They have to work together. Just like an engine, in all the systems, base oil and additives have to work together. There's not like one without the other. So Lubrizol, Afton, Ornite, and Infineum are the 4 companies that make the additives. They're the guys who make molecules.
Got it.
We were fortunate enough to be working with Lubrizol during that time, and we were able to learn a lot of things that most people would never be privileged to be able to learn because of our relationship with them. And we're fortunate enough now in a position where we can share that and help people make good decisions and cut through all the marketing fluff and get to the facts so they can get on and have fun with their car and not worry about it.
So when your dad was racing, right? The engine, were they breaking them down after every race? I think I heard one of your videos where, because of technology, because of the oiling that we have, or the lubrication that we have, I should say, that you're getting more races out of the bottom end, maybe, right? Or is that not accurate in every?
Well, no, yeah. So in the old days, you go back 20 years ago, just give you an example. NASCAR engine back then, still turning around, 9,500 RPM, 9,200 RPM. No, not much different than today.
Right.
Engines made about 700 something horsepower back then. It was pretty normal, maybe low 800s. Well, those engines would last one race. They'd be down 500. I mean, they'd be down 5 to 8 horsepower. Pretty common. You have to hone the engine out a few thousands to clean it back up. Back then we used, 043, 3mm ring packages. They were the ductile moly type rings. That's a ductile iron ring with a moly face coating, like we mentioned earlier. But today, those teams now will go 4 races on that same engine before they rebuild it. And they're basically down nothing on power at the end of those 4 races. They just change it and rebuild it because they're worried that it will break, or something else will fail. And they're using 0.5 millimeter, 0.6 millimeter, 2 millimeter ring packages. Just, I mean, it's a massive difference. So we've basically tripled the life of these engines, but we've done it through material technology in terms of the rings and the coatings, the oil technology, how we hone it, the tribology, right? We applied tribology to these engines, made massive gains. And what really enabled the teams to begin to look this way was, we know at Gibbs, when we were building engines, we would build a short block for, say, the Xfinity series, and we could run that engine a couple of races because that was the rule. It had to run 2 races. Then that same engine could be just redo the heads, keep the short block together, put it in a truck, and it could run a couple more races in a truck. All right, well then redo the head, swap the cam again, and go put it in an ARCA car and run more races. And we were like, these things don't, the bottom end's not giving up. The vacuum's not dropping off. The power's not dropping off. These engines are running 3 times the mileage of what was before. Maybe we could get away with running these things further. And then as the budgets got constricted and COVID and everything, they realized, hey, we can do this. And they jumped off a cliff and realized they could go even further than we thought we could back then. So big game changer.
Yeah, and you're not seeing a lot of engines go anymore. I mean, I've noticed that when I watch it, it just seems like, I don't know, just they're put together a little bit better, and with technology. Well, if someone's watching this, like I said, from a forum or even on our YouTube channel, and you have an off-road vehicle, right? This is where it comes in. If I buy, let's use my Bronco. My wife has one. I have one. I have a 2021 Badlands with a 2.7 in the Sasquatch package, right?
Yep.
When I got that Bronco, I drove it. I was kind of easy on it. I didn't really drive it too hard at first. And I did an oil change at I think it was 1,500 miles. And I filmed it. And at the time, we had a question, 6 quarts or 7 quarts. Originally, it was 7 quarts, and they've since adjusted it to 6 quarts, right? So I did this oil change where we tried to discover where the 7th quart was, and people was draining oil, and they had a slow drain back at first. And what I found was the opinions about how I was wasting my money to change the filter and the oil at 1,500 because the owner's manual said 10,000. And you have people that have the opinion it's 500 miles, it's 3,000, it's 10,000. Some people just do it at 5 and are done with it. Well, here's what I did: 1,500, which probably should have did it sooner. 1,500 and every 5,000 now, and I switched over to full synthetic. Now, what I did notice on my very first oil change, we had small aluminum, particles in the filter itself, which I would expect. But when you do an oil analysis at Speed Diagnostics, because that's something I'm going to put in a comment below, that if you want to get your oil sampled, here's where you can do it. You're noticing, like for a video for, I think it was your daughter's car, you did a oil change on it, and then you followed that up and you compared the first oil sample, the second oil sample, and you can show with science that there needs to be break-in change. And what was that about?
Oh, so the highest time of normal wear in any engine. So I'm not saying an engine failure, but the highest normal wear you're ever going to see is during engine break-in. All those parts are still mating together. No matter how smooth we have them in the factory and what coatings we're using, there's still going to be wear. And oil filters do not capture 100% of all the particles generated. They just don't. We wish they did, but they don't.
Yeah.
So what happens is that metal debris that's generated by break-in goes all through your engine, and it generates more wear throughout the engine. And no, you don't need that to get the parts to break in. That's old school thinking. You got to wear the engine in. No, we don't want to wear the engine in. We want to allow them to mate with the minimal amount of wear needed, and then get on with life.
Right.
shorten the interval up, not drag it out and take life out of the engine. So with like my daughter's car, we went 722 miles and took that first sample. Then we went about 2,500 miles and took the second sample. And we went from basically 90 parts per million total metals per 1,000 miles. And we dropped it down to 9 parts per million.
Whoa. So say that 90 to 9?
90 to 9.
That is night and day. Yes, absolutely. Oh, yeah. So that particular engine tells you that you should, right?
Oh, and I've seen tons of engines just like yours. So we've probably in the last month or so, we've probably analyzed 3 or 4 different brand new Bronco engines right from the factory. And, things like copper, they wear at a higher rate, especially during braking because they're softer. And those stuff goes everywhere throughout the engine. So what we've seen is that when people are taking samples or draining the oil at a shorter drain interval, say 500 miles or so compared to say 1,500 miles,
right,
the total amount of wear in the engine is much lower on everything.
Gotcha.
So it is to your favor in terms of if you own it and you plan on owning it for a long time,
right,
especially with turbocharged engines, the turbo bearings, that's what you're getting a lot of this wear from copper. You want to go ahead and get that oil out, change that filter, put in a fresh filter, fresh oil in, and you're going to be able to extend the life of your engine long term by doing that. And then you can basically establish that wear rate. You can begin to look at what's going on. Because the longer you go, things like copper act as catalyst. So they can actually deplete the additive package and cause oxidation, which will shorten the life of the oil. So, you have to understand that these OEMs, these engineers, they are trying to do the best job they can in terms of making a good product. But they can't solely focus on you, the consumer, and what your needs are. They have this very large governmental agency called the EPA that is, if you've ever been around a farm, you can take, a giant, 3,000-pound bull and you can put a ring in its nose and you can lead that sucker around wherever you want him to go.
Yeah.
Well, guess what? The EPA is the ring in the nose of the OEMs,
right?
And they're telling them what to do.
Yeah.
And so longer drain intervals are part of lower the cost of ownership, and it reduces the amount of waste oil being generated, and they get credit for that in terms of their CAFE requirements. So it's not as straightforward as, well, these guys are super smart engineers, and so whatever the book says has got to be the very best thing for me.
Yeah, and that's why they're saying 10,000 is because we're having to mitigate all of the politics into that.
Right.
And something, by the way, I'm not on, I don't own an EV, so I'm not on that right now. But one thing I will mention is one of the engineers at Ford, they were talking about the Mustang, and they said, diehard Mustang guys don't like the Mach-E's. And he said, but just consider for every Mach-E sold, there can be another gas engine sold. So that's part of that CAFE standard, right? But yes. I don't want to get too far off of that. So that is part of the recommended 10,000. So it's not the science or opinion. It's not the opinion. It is the science. You were able to show it in the oil analysis that you were able to drop these metals. Now, these metals are mainly coming from cylinder sleeve, bearings, and what else?
You got piston rings, you got cylinders, you got pistons, you actually have valve train, you've got timing gears, bearings from the turbocharger. All these different parts of the engine, they're all going to have some initial wear that begins to come in, and getting all that stuff out, cleaning the system out is really important, and then putting in a good oil and then going from there. And I'm not big on brands because I know that every brand buys their base oil from a handful of companies and everybody buys their additives from a handful of companies. The nice thing that you mentioned earlier about using Motorcraft was that the Motorcraft oil has been running those engines because that's what Ford factory fill. And, they work with ConocoPhillips. That's who they buy the base oil from. And ConocoPhillips probably buys their additive package. I think they buy from Afton because a lot of the Kindle is one of their products, and they had the titanium additive in there, liquid titanium, and that comes from Afton. So yeah, they've done engine testing. They know that using, even at 10,000 miles, they can use that oil in their application, and it will get you through warranty. Because that's their only concern.
Yeah. To get you through warranty. And if you're leasing it, I saw a video that you did, and I'm gonna probably have like 3 videos posted. Obviously, when you go to his channel, when you go to Lake's channel, you're just gonna the Motor Oil Geek, you're just gonna start getting into these videos, and it's hard to stop watching them at first because the knowledge you have is incredible. By the way, I'm honored to have you on our show because of the wealth of knowledge. Sometimes I feel like it's not worth the argument, you know, if I do an oil change video and I get told in the comments that you shouldn't do that. And I'm going to jump into 2 more things here real quick, but I really appreciate you being here to help clear the air. The science behind this, not opinion. It's not what we heard or what we used to do. It's science. So we've talked about the wear versus friction, 2 different things. We can maybe get into that a little bit later as far as the additives, or you're calling it the packages, right? Mm-hmm. Or the detergents. So rings under load. Here's the big thing: to purge or not to purge. So we have the anti-flood, or whatever you call that. I call it the pre-purge, where accelerator down, brake down, start. It doesn't fire up. It just turns over. We're purging the engine. You did a video to where you pre-filled the canister filter, and that kind of lit the internet up, right? Because it was unfiltered, but it was new oil.
Right.
So should you purge an engine, or should you pre-fill a canister filter if you have the option of it hanging from below?
Yeah, if the filter's hanging from below, then the best thing you can do is just put oil in the filter so that you don't let the engine run without oil momentarily. People said, it doesn't matter that much. Well, stay tuned. We're going to have a video coming out. We've quantified the effects of that because people ask the question, well, let's show the science behind it, not just the theory. If you have a filter that's mounted on top, or a canister where you can't do that, the best thing if your car does have, clear flood mode, something like that, where you can push down both pedals, and then that's good, because even though, yes, the engine's moving when you're doing that, the key is you're not putting any fuel and you're not putting any combustion to it. So you're lessening the impact of that rotation without any load. Because without any load, everything's way easier. When you have the big load and you have fuel, that's what can cause the wear. So, those are both good strategies. Again, if you own your car and you're trying to take care of it, again, it doesn't take any extra time, really. Just a couple little hacks to kind of shortcut and get more life out of your engine.
Yeah, and there's something to be said about that. When you're firing it off, right? The combustion process puts a tremendous amount of load. You can see an engine breakdown. You can look at rod bearings and see wear from engines that's had a lot of knock over the past, where you're really banging the bearings up. There's something you know it probably better than anyone, LSPI. I want to move into that a little bit and how to prevent it. Not that we have any issues directly with it right now with our stuff, but when we get into the detergents, most oils are calcium based, but is there magnesium as well? And which one is better for preventing LSPI?
So the great thing is, low speed pre-ignition LSPI is a type of detonation that can destroy engines. The good news is if you just go buy an API SP rated oil, you're good, because there's actually engine tests specifically for LSPI and the effects of these things, where for that oil to have the API SP rating on it, it had to pass that test. So that's the good news. To do that, what they've had to do is change the detergent levels. In the old days, we had calcium levels over 2,000 parts per million, very little magnesium, sometimes even had some sodium. Well, sodium and calcium can cause low speed pre-ignition. So what's happened today with the SP oils, to prevent LSPI, you now have calcium levels under 1,500 parts per million. you've got some boosted level of magnesium, and sodium is basically gone out of the equation, because sodium was the worst for low speed pre-ignition. So that reformulation is taking place. Now, the key thing is, a lot of people in the old days really clung to like Rotella T. They would use diesel oils because they had higher zinc levels. The problem with those older diesel oils, they tend to have very high detergent packages, high levels of calcium. So it's not advisable to use those kind of oils, regardless of what your past experience has been.
Right.
In a turbocharged direct injection engine, it's best to just use API SP. And, you know, the key thing for all of this is, as the consumer, before you make any decisions about what oil to use, how often should I change it, what kind of filter, and all these things, you need to decide what kind of student do you want to be. And what I mean by that is, do you want to be the C student? You know, C's get degrees. Do you want to be a B student, or do you want to be valedictorian? I'm the guy that can teach you how to be the valedictorian. If you just want to be the C's get degrees, life is pretty simple. Go to the back of your owner's manual, look up what viscosity and what specification that it calls for. Go to the parts store and buy whatever brand you want that has that viscosity and that spec. Follow the owner's manual. There you go. You don't have to do anything more than that. You'll get through warranty, and if you don't, they'll cover it. Yeah. That's simple.
That's right. And if you don't do your own oil change, you take it to the dealer. I don't know of any dealer that would deny you an oil change prior to the 10,000 mile interval, right? I'm sure they do it once a month.
Some people don't argue with you and say you don't need it, but it's like, I don't care. Do it.
That's what I'm going to do.
Right. But the other thing is, so if you want to be a B student, do everything I said about being a C student. Then what you can do is make sure you're using a synthetic. Right? Same rules, spec, viscosity, make sure you're using synthetic, full synthetic. Change it every 5,000 miles. And when you do that oil change, put a bottle of polyetheramine-based fuel detergent additive in the gasoline. So there's lots of brands. Chevron is actually, because they own Oronite, one of those 4 additive companies. They invented the polyetheramine chemistry. That's what's in the Chevron Techron. That's this one that's readily available. But, you know, Gum Out All-in-One has it. Redline has one. There's a bunch of different brands that have PEA-based fuel detergent additives. That's the key word, PEA, polyetheramine. If it has that, it's good. But the one that I really like is that's easy one to get is either the Chevron Techron Complete, not the regular Techron, the Complete Fuel System Cleaner. That one's really great. Or the Gum Out All-in-One Complete Fuel System Cleaner. Those are kind of the key words. The Complete means it's not just a little bit of detergent. It's got more stuff to it, which is good. And just put a bottle of that in your fuel when you do that oil change every 5,000 miles synthetic. Hey, now you're a B student. You're doing pretty good. If you want to be valedictorian, that's where you have to add in the used oil analysis, because now you're going to be able to get feedback. You're going to get data, and you're going to see, okay, where am I in terms of my wear rate per 1,000 miles doing this? Where's my fuel dilution? Maybe I need to use that a little more often because the gasoline where I am is junk and I'm getting injector deposits and I'm getting more fuel dilution. Maybe my wear rate's high, so I maybe need to try a different brand of oil to get my wear rate down below 5 parts per million per 1,000 miles. So without data, you can't make good decisions. So if you want to be valedictorian, you're going to have to try a little bit harder, and used oil analysis is that tool that gets you to that next level.
Yeah. And, you know, with these direct injected, well, the 2.3's direct injection only, the 2.7 is dual, but that dual, from what I understand, port injection is really low speed at idle. Mm-hmm. Everything under, you know, high speed, torque, you know, acceleration is just in the cylinder, which brings me to the fuel treatment. If you're not spraying down in that pocket, that injector pocket in the piston, and you happen to spray on the cylinder wall, that can cause wash, right?
Oh, absolutely.
Yeah. So
High fuel dilution is high wear. That's the one thing we see with oil analysis more than anything else. Brand doesn't make a big giant difference in engine oil results. What makes a big difference is fuel dilution. Whenever we see a higher level of contamination, be it silicon from the environment because someone decided to put on this high flow air cleaner that let more air in the engine, but it also let more dirt in the engine, you'll see increased wear. If you have dirty injectors, which aren't atomizing the fuel properly, you're going to get more wear. So the higher the contamination, the more wear you see, and that's what we see more often than we see anything else.
And most conversations never ever connect fuel and oil changes. Yeah, how frequent should you do it and things. So this is really good information. The fuel treatment and the type of fuel that you have in your part of the country, or your part of the world, wherever you're watching this, is could be more of an impact to the oil than in other parts. So it's being the valedictorian. Obviously, you're doing this analysis, so you know what you're getting. Now, you just mentioned silicone as part of your environment that you're in. If I told you I had a 21 Bronco with a 2.7, and that's all I told you, and the mileage, and I sent you the sample, but I didn't tell you how I drove it, whether it's back and forth to the mall or work, or if I went wheeling on the weekends, could you tell that in an oil analysis how I drove?
I can tell you if it got dirty or not.
Right?
Sometimes you can kind of get a little bit of a glimpse, because again, fuel is the enemy of your oil.
Got it.
So if you have a newer car and let's say there's a lot of idle time, maybe slow running, things like that, and we got back to, well, this mileage is pretty short, fuel dilution's really high. Okay, did you do a lot of short trip driving? I could infer from that. Now, that short trip driving, be it off-road or on-road, I can't tell you that.
Got it.
Now, if you saw a bunch of silicon out there, we would say, okay, hey, maybe, are you in the desert? I mean, you look at your phone number, say, okay,
we're
801, you're in Utah. Oh, you've been in Moab. All right, I got it.
Yeah.
I know what you're doing down there. Yeah, you probably should invest in a better air cleaner or do something like that because you have high level of silicon getting in. But I know it's a dusty, dirty environment. So a lot of times you just respond to the environmental concerns. That's the guys who are building these cars are trying to make sure they can cover a giant spectrum. They got to cover from Canada down to Florida and everywhere in between. And that can be challenging sometimes.
Here in southeastern Virginia, our wheeling is a little bit in the mountains, but mainly we go to the Outer Banks. We're on the beach, right? It's not anything crazy. It's just typically it's a high torque. When you're in sand mode in the Bronco, it shifts higher RPMs, carries the gears longer. So you're turning higher RPMs to go 15 miles an hour, right? So if you're driving all the way down Corova Beach and back, and you're idling a lot, you have sand blowing, right? So wind's blowing some days, depends on if it's rained recently or not or whatever. So you have the dirt, you have that environment, you have a lot of low speed. So your transmission temperature goes up, your engine oil temperature goes up because I've monitored it. I'll watch the temperatures on the telemetry and say, wow, I couldn't believe that the transmission increased that much or the oil increased that much because we're not moving all that air across the radiator.
Right.
In the intercooler, well, really the transmission cooler for that. But I just thought it was interesting that when we add all of that, so whatever type of environment you wheel in will also determine. So if you do an oil analysis, speed diagnostics, if you just go to your website, I guess, and instructions are there, get that sample for your Bronco. That way you don't have to rely on your uncle or what someone told you down the street or whatever. You get to see what's happening with your vehicle, Bronco, Jeep, 4Runner, whatever it is. You get to see what's happening with your vehicle and the way you drive it. So maybe you're driving it back and forth to the office during the week and you're in the mountains on the weekend. So you get to see, based on the oil analysis, well, what's the condition of oil and how often should you change it? So that
because it will vary based on who that person is. I mean, one of the funny things is we used to play this game at Joe Gibbs Racing that the engineers would take samples from the different cars after each race, and they had sent it off. And I had this little game we would play where I would not look to see what the car number was.
Yeah.
And I would guess what the car number was by the results, because, you know, one of our drivers back then, he was really heavy with trail braking. So every time he entered the corner, he was dragging the brakes. Whereas the other guy, he would float. He was a, you know, off the gas coast kind of guy. And so I could tell whose it was. I could tell Denny Hamlin from Kyle Busch every single time.
I mean, of course, that's racing, but still, like you said, no two Broncos are going to be the same, I guess.
No two drivers are going to be the same. How
exactly?
You know, how hardcore do you go? So that's part of the problem. Like you said, the great thing about the internet is we all get connected. The bad thing about the internet is we all get connected.
You know, so opinion gets a connector, right?
Well, the problem is we're not communicating all of the details. You know,
sure.
You got the same Bronco I've got. We're both off-roading. Okay, on the surface, that sounds like it's the same.
Right.
But someone could be at, you know, a mile elevation in the cold, in the sand blowing, and someone else is at sea level in the swamp with water going everywhere.
Right.
And those are going to be very different environments, despite it being the same vehicle doing the same thing. It's not the same. And that's where that little bit of detail can actually make a giant difference in terms of what the proper maintenance strategy is and how to really maximize what you're trying to accomplish. Again, this is the racer mindset, right? I worked for Chad Canals, who was Jimmy Johnson's crew chief years ago. And the way you win the pole at Daytona isn't by finding this one magic thing. That's not where the speed is. The speed is in stacking 10 small things together to get to that 1 second advantage. That's how you do it.
Right. And so every single thing that we can do, for example, every modification you make to your Bronco can change it as well. Tire size. I mean, if you're at a 33, you know, non-Sasquatch Bronco, and then suddenly you have 37s on it, you have a lift, you have more drag. You're going to the OHV park. You're going somewhere wheeling a lot more, but now you've changed the intercooler. You've added a tune. Suddenly now the tune is changing, right? Timing, changing fuel. So now potentially that oil sample that you did before you did the tune, you know, you're going to see a difference, right? Yep. And then also now you have an off-road machine, so you're driving a little harder. So it starts stacking out. I don't think most people, they think that it's not that important. And obviously I didn't care because I did it. I filmed it. I put it on YouTube, and I knew I was going to get the feedback. It's totally ridiculous, or I do it on every time. And so I like, if you have a Bronco now, you just bought it, you have less than 1,000 miles on it, just consider doing an oil change, taking the sample, and then doing that's your baseline, right? New now. And then at your next oil change, maybe in 5,000 miles, do it again and look at the numbers and see what the wear metals, right?
It should drop down and then stabilize. Once you find that stabilized point, now that's your baseline you can compare from going forward. You know, what you want to see that to make sure that it's dropping down nicely. And then the nice thing is, why do you need that high number? Well, that high number is the high watermark, because in the future, if those numbers ever get close to that initial number again, that's the indication there's a problem.
Right.
That's why they're so important.
Gotcha. So your engine's talking to you through the data that you're able to grab from the oil. So, all right. So we mentioned, obviously, check with whatever specs that the owner's manual says. That's what you want to definitely, I guess is important. And we talked about the type of oil and what ratings on it. What about oil filters? Is there a rating on an oil filter we need to be concerned about, or is it just more brand?
That's a giant can of worms to get into.
Okay. So that's another video, another time.
That's a whole nother video.
Okay, got it. Yeah, sounds good. Yeah, because that, and I use, for everyone watching this, I use Motorcraft, the OEM style filter. I change my oil plug after every oil change because it's the plastic one with the rubber O-ring. If I had the aluminum pan, then I would reuse it. Crush washer is a little bit different. Well, I don't want to keep you too much longer. I have just a couple more questions. Real quick, is it an easy answer if I ask you what causes sludge? What is the
moisture?
Okay.
Low temperature operation. The ASTM sequence 4A is the sludge wear test. And that test actually has a water jacketed valve cover. And so they run the engine at low engine temperature. So operating at low engine temperature is what generates sludge.
Got it. Let's wrap this up. I appreciate your time. I really do.
I'm happy to do it.
Wealth of knowledge. And let's see, we've talked about wear and friction. We've talked about different oil, sludge. Is there anything that I need to ask you that would really benefit our viewers?
Well, I think we touched on all the key things. Fuel is the enemy of your oil. So you want to make sure that you're keeping that fuel out. Any other kind of contaminants like sand, moisture, things like that, those are the bad things. So that's why having a little earlier oil change interval is always a good thing, because it reduces the risk of there being a buildup of contamination that can cause issues. So again, back to what we said, you have to decide on the front end, what kind of student do you want to be? You want to be C's, get degrees, or you want to be a valedictorian? Once you know that, you can pick your path. You can follow it there. This isn't rocket science.
Right.
It's just about making good decisions based on the science, as opposed to marketing, or we'll call it compromised advice, because you have Environmental Protection Agency that has an agenda that it's trying to enforce. And that agenda doesn't always align with what's actually best for the long-term health of your vehicle.
All right. So I want to wrap this up. Lakespeedjr, you're awesome for being here. I appreciate you doing this. And I just want to add value to the people watching our YouTube channel and on the forums that maybe this is going to be shared on. So look, I don't mean to get it going again, because somebody will say, oh no, here we go again. But this is the first time that I've seen a video, at least we've done, and on the forums, that is science-based, not just opinion. So the enemy of our oil, or I guess to say the mini, is fuel dilution, right? The fuel. So adding a fuel treatment to keep our injectors spraying properly into the piston or the injector pocket, or not on the cylinder walls. Dirt, if you're in a dirty environment, you're driving it, you're off-road a lot, then that's another reason to change your oil sooner, or at least have it tested. Driving style, so how you drive it, how hard are you on the gas and off the gas? Are you cranking it up, driving 3 miles to work, cutting it off? That type thing. And then what kind of student do you want to be? C, B, or valedictorian? So the idea is that if this Bronco is long-term, or this Jeep, or this 4Runner, or whatever it is that you drive off-road, if this is long-term and you're towing your boat back and forth to the creek on the weekends, and you're driving it to work and you're wheeling, this is something that you want to protect the engine. And the oil analysis, if you go to speeddiagnostics.com and just look and see what it takes to get the oil analysis, follow the instructions, get it done. And if nothing else, you have a baseline for where you're at. Lake, what else should we, in closing, anything that we need to add, or are we done?
That was a great summary, man. You paid attention. This is great note taking there. That's fantastic.
Hey, well, I mean, it just wraps it up. It's where I just want to help everyone. And I know from building engines, I told you before this, we recorded this, last engine I built was 2003. So I've kind of been out of it for a while. Obviously things have changed dramatically since then, but I just know that the importance of these engines. So, well, look, I appreciate it. Real quick, I'm going to put it in the comments below, but if somebody wants to watch your content or check you out on social media, where should they check you out at?
The Motor Oil Geek on YouTube is my channel. It is loaded with great stuff about oil. If you love engine stuff, go to the Total Seals YouTube page. We have tons of dyno testing stuff. I mean, Greg Anderson honing my dad's block. Those are two great channels that have just tons of content. And if you really are a deep motorhead and love listening to some awesome stories, we actually have a podcast, Hidden Horsepower. It has its own YouTube channel. So there's lots of deep dive content available. Motor Oil Geek, Total Seal, Hidden Horsepower. Enjoy.
Great info. Great info. Well, Lake, thank you very much. I appreciate you doing this. And check out his channel. Seriously, I've been watching the videos, and I will say this, your head will hurt if you watch too many at one time. So pace yourself because there's so much information here. It's incredible. So Lake, appreciate it. Thank you very much.
Thanks, Wayne.